super excited, just about to do a live reading of My Discovery Lab and the Big Blast Off. So super excited. I hope you are doing well this morning and enjoying the Dubai summer. I just wanted to do this little live session to introduce you to this book that was written by me, Nicola Fisher, and also my good friend Samantha Armstrong. So I'm the scientist out of us, and my friend Samantha, she is just brilliant with words. So together we put this book into production. So what is it? It's a science story that helps to teach about forces and motion, because children learn really well when they're engaged with their learning. So I'm going to read you this book then, to give you an idea of how to engage children with such a cool topic of forces. So we have got 3 characters in this story. So here is the book then. It was a day for exploring at the My Discovery Lab. Marie was reading to Robot and Newton from her book about rockets. Buckle up, astronauts, we're going into space where there are billions and billions of twinkling stars, she said. Ready, 3, 2, 1, blast off. Now, as you can see, we've got some nice graphics here. Everyone squeezed their eyes shut, imagining they were travelling up and away. Rockets zoom into space using something called force, Marie told them. But wait a minute, and here is the inquiry-based bit, because good stories encourage children to ask questions, to make observations, and to ask questions. And that is the very essence of science. So here we go. We have a question from Newton. But how do forces make rockets move? Newton asked, looking puzzled. So this is when you say to your children, yeah, let's think about it. Rockets blast off into space. They have to overcome the force of gravity to take them out of the Earth's atmosphere and up into space. How does this happen? How does it happen? So there we go. You've got children thinking about how things move. Okay, forces affect everything around us. They move objects and stop them by either pushing or pulling them, Marie explained. Now, this is when you say to children, okay, so a force is a push or a pull. So let's think about the forces that we have used today. Because when you are encouraging science learning, it's really good to look at everyday situations. So you could say, let's go around the house and see how we're going to use some forces. You could pull open the fridge door. You have used a force. You can push a door closed. You've used a force. Even when you are walking and you're pushing and pulling your legs, you're using forces. When I'm talking to you, I'm using a force. So forces are indeed all around us. Now, pictures are good in a story as well, because when you're reading to children, the best thing to do is to say, right, what can you see here? What's happening here? So you're engaging children with the story. So they could say, oh, wait a minute, what's happening here? We have got Newton, we've got Robot playing with a toy car, and suddenly it bangs into a wall and it stops. Shh, Robot, I'm trying to listen to Marie, grumbled Newton. It's okay, Robot is actually helping us understand how forces work. The car uses energy stored in a battery to push it forward. But the force of the wall is much stronger, so it stops it moving when it bangs into it. Now this is my favourite part, because again, for children, connecting their learning to everyday things is so important. So here we go, it's a bit yucky. Wow, forces affect lots of things we see and do, thought Newton. Just then, his nose started to itch. Achoo! There's a pretty strong force right there, chuckled Robot. And as you can see, we've got some lovely snot hanging out of Newton's nose. Because you know children love to talk about snot. But there you go, you can say actually it's a force that helps expel that. Robot loved finding out about things. He knew that rockets fly super fast because of their special shape and the way the different parts are put together. And this is when you bring in more learning in your story and you say, right, okay, what shape is a rocket? Do we know what shape is a rocket? Okay, well, this says, turn to page 22, where we can have a look at a rocket and label the different parts. So you can go to page 22, and there's actually a picture of a rocket that you can discuss and label. And then you can say, why is it pointed? Why does it have that pointed shape? And children might start to bring in words, or you can help bring in words called aerodynamic. Then you can open up to discussions about why sports cars have that smooth, streamlined, aerodynamic shape to help them make them go faster, to cut through the air, to reduce friction. So you can see even a simple story where you're reading it to children who are 3 and 4, if they're 5 and 6, you keep expanding out on the science that you are discussing. So really, stories are a great way to engage scientific inquiry skills. So this is why we wanted, myself and my friend Samantha, wanted to put this story together. Because for me, especially, science is all around us. And the magic of it is when we open children's eyes to it. So, we'll keep going. Now, I'm never just going to do a story where children don't have to actively do something, because at My Discovery Lab we say explore, discover and investigate. So here we go, it's an interactive book. We want the children to do something as well. Newton was getting excited. He wanted to make his own rocket blast into space. Sorry Newton, it takes really clever engineers and scientists to build rockets, Robot told him. Robot was right. Real rockets need forces and fuel to give them a big blast of power. But maybe there was another way. Wait a minute. My book says we can build a straw rocket to launch, noticed Marie. So here we give you instructions. Now this is very easy to do, and you can do this at home with materials. And it gives instructions of how to make a straw rocket. Just like one of these, and you can get super creative. Now, if you want to use a bit of technology as well, we give you a QR code, and you can scan the QR code to go to a little video of how to do the straw rocket as well. So you can bring in some use of technology if you want there as well. Okay, here we go, back to the story. Newton clapped now because he just built this straw rocket. Now I think we put the smaller straw into the bigger straw and we blow. Look, it worked. So what did Newton do? He did a little blast off. You try, Robot. But Robot's rocket didn't move. So Robot tried to blow into the straw rocket, but it didn't move. Poor Robot, what went wrong, Newton wondered. And this is where you say to the children, okay, so why is it then that when Newton blew, his rocket launched, but when poor Robot tried to blow into it, nothing happened? So you get children to make that observation. What's the difference between a robot and Newton? Looking at our book, Maria discovered that blowing air into the big straw created a force that pushed against the small straw, sending the rocket flying. It's because you don't have any lungs to blow with, Robot. Ah, yes, you're right, he laughed. I might not be able to blow, but I can use my design skills to make the rocket look really cool, said Robot. Now, this is the good part as well with an activity like this, because when you're doing science, you can also encourage children to be really creative. So when you're making this, we have a design template for you. So it can be cut out and it can be coloured, painted, use crayons, anything you like. But you could also say, right, what would happen if we made the rocket even bigger? Would you like to design your own one? Let's draw out your very own rocket, what shape you would like, and let's make a new one. So creativity goes hand in hand with science. Now, what does the book do? That's about 2 or 3 or 4 times so far. It's reinforced this concept of forces, but it continues again. Now, I can't get the glitter off, Robot cried. Don't worry, I think we can use what we've learned to fix it, said Marie. We just need a bigger force. 3, 2, 1, pull! Look, everyone, Marie, what does it remind you of? Look at this lovely page. Lots of sparkly stars, said Newton. Well, it looks like I launched my rocket into space after all, grinned Robot. So there we go. Now, with this book, what do we want? We want creativity. Children to explore what forces are and get them thinking. So next time you go to Spinneys, you say, right, okay, are we using forces? Yes, we're pushing the shopping trolley. What else are we doing? I am pulling the fridge door open. That's correct. And actually, you can get forces when you push the trolley sometimes. It depends what shoes you've got. You get little friction forces there too. But what else do we include in this book? We give you explore more opportunities. So when you're a scientist, you know, making this straw rocket is great and it's creative, but there's so much more you can do with it to engage children. Get them inquiring. Okay, so what is going to create the biggest force now and make my rocket go the highest in the air? You can have a competition with the siblings. So, is it going to be a small puffer bear or is it going to be a big puffer bear? Ask the children. Get them to make the questions, to make a prediction of what they think will happen, test it out and observe, and then make a conclusion. So, here's a little one. Little one. Here's a big one. And it went much higher, didn't it? What about the angle of launch? So does that affect the distance that it travels? What about if you make the rocket out of a different material? So you use tin foil, aluminium, whether you use some sort of plastic sheeting. Does it affect how easy that it moves? So, what do we want to show you with this book? Want to show you that science can be so super creative. And this book is just a little introduction of how you can do this in a really simple way. So, how can you get this book? It's only 35 dirhams and you can buy it on our website, which is www.mydiscoverylab.com. And if you do like this sort of activity, but you don't want to have to go and buy all the different pieces to do experiments, then do check out our boxes. We've got a super one called Blast Off, which has got 5 amazing rocket experiments to include this one. I'm going to finish with this one because you're going to love this. And what kid wouldn't love to experiment and learn about forces with something like this? So here I've got a little canister and I can put in some water. Now, all throughout the My Discovery Lab box, we're learning about forces, push, pull, what creates bigger forces. So you can put in a vitamin C tablet. There's going to be a chemical reaction inside there. Now, what have I got to do? I've got to put the lid on, and then 3. Did you hear that? It went pop, and it hit my roof. What kid's not going to love that? But before I finish, a lot to learn here. If they're younger, you're learning about forces in motion. Okay, so there's a chemical reaction, pressure builds up and a force launches up the way. As children get older, you can talk about Sir Isaac Newton's laws of motion. And one of the laws is that for every action, there's an equal and opposite reaction. So when a force pushes down, there's an equal and opposite force pushes up. And that's actually how real rockets move into the air, because when the fuels burn, it gives off the gases. As you can see, the flames sort of coming out. But what that does is it creates an equal and opposite reaction in the other direction. So it sends the rocket into the air. So there you go. Science is literally all around us. So thank you so much for joining me. And if you've got any questions, then please do fire away on Instagram, mydiscoverylab.com, and I'll get back in touch with you. Thank you.